In 2013, a neuroscientist named Jimo Borjigin at the University of Michigan put electrodes into the brains of 9 rats and stopped their hearts. She wasn't trying to kill them for no reason. She was trying to answer a question medicine had somehow never answered. What does the brain actually do in the seconds after the heart stops? The assumption for over a century was simple. The heart stops. Oxygen stops. The brain shuts down, fading like a dimmer switch turning slowly to black. That is not what she found. In the 30 seconds after cardiac arrest, the rats' brains didn't fade. They surged. Electrical activity spiked into a pattern called gamma oscillation, the same high-frequency signature seen in a fully conscious, alert, focused brain. Not weaker than waking life. In some measures, more synchronized than waking life. The brain, in the act of dying, looked like it was doing the opposite of dying. That single result would go on to become one of the most cited, most argued over findings in modern neuroscience. And 9 years later, doctors would catch something almost identical happening in a human being, by accident, while he was already dying in front of them. Here's the paradox at the center of all of this. The brain is the most energy-hungry organ in your body. It burns through roughly 20% of your oxygen supply at rest, despite being 2% of your body weight. Cut that oxygen off, and you'd expect the system to fail the way any starved machine fails, sputtering, weakening, going dark. Instead, in the window right after the heart stops, something fires up. For decades, this fact sat buried in obscure physiology journals because almost nobody was looking. Death medically was treated as an event, a line you cross, not a process you could put under an EEG and watch unfold second by second. Borjigin herself has said she was startled by how little anyone actually knew, not because the data didn't exist somewhere, because almost no one had bothered to record it. So the question isn't really what happens when you die. It's stranger than that. It's why does a starving, failing brain spend its very last working moments looking more switched on than it does on an ordinary Tuesday afternoon? The 2013 study was published in the Proceedings of the National Academy of Sciences, one of the most rigorous journals in American science. Borjigin's team wired up 9 rats with intracranial electrodes, induced cardiac arrest, and recorded continuously through the entire process. What they measured was gamma oscillation, brain waves in the 25 to 100 hertz range. In a normal waking brain, gamma activity is the signature associated with focused attention, sensory binding, and conscious perception. It's the frequency your brain runs at when it's pulling together sight, sound, and memory into one coherent experience. What neurosurgeon Ajmal Zemmar at the University of Louisville has described as the brain's way of welding scattered sensations into a single object you can perceive. In the dying rats, gamma waves didn't just appear. They became highly synchronized, more coherent across brain regions than during ordinary waking states, and this surge consistently occurred within the first 30 seconds after the heart stopped, right before the EEG went flat. 30 seconds. That's the entire window. Stack that against an ordinary breath, which takes about 4 seconds, and you get the scale of it, roughly 7 full breaths worth of time. And within that narrow gap, the brain runs one of the most synchronized electrical patterns it produces in an entire lifetime. For a few years, the finding sat there. A striking result in rats, hard to extend to humans, easy for critics to wave off as some artifact of rodent physiology. Then, in 2022, a human brain did the same thing, and nobody had even meant to record it. Here's what most people don't realize about how that human data was even collected. Nobody designed an experiment to watch a person die. It happened by accident. At a hospital in Estonia, Dr. Raul Vicente and his team had an 87-year-old patient hooked up to continuous EEG for an entirely unrelated reason. He had epilepsy following a head injury, and doctors were monitoring his seizures. While the recording was running, the man suffered a sudden cardiac arrest and died, the EEG capturing every second of it. For the first time, scientists had continuous brain recordings from an actual human being before, during, and after the moment a heart stops, instead of inferring it from rats. And here's where it gets strange. In the 30 seconds surrounding his death, the man's brain showed the same family of oscillations linked to memory, recall, dreaming, and meditation, cross-frequency coupling between gamma and alpha-theta rhythms, the exact electrical signature healthy brains use when pulling up a memory. Not even close to silence, not even close to a slow fade, a burst of organized, memory-linked electrical rhythm happening in a brain that, by every clinical measure, was already shutting down. The researchers were careful, almost defensive, about what this didn't prove. One man, a brain already injured from a fall. No way to ask him what, if anything, he experienced. The result was picked apart for exactly those reasons, and rightly so. You cannot build a theory of death on a single case. But the pattern itself, the gamma surge tied to memory circuitry, was the same pattern Borjigin had already found in 9 separate rats 9 years earlier. 2 species, 2 different labs, the same electrical signature, lit up at the exact moment everything was supposed to be going dark. Borjigin didn't stop at rats. In a follow-up study, her team at the University of Michigan monitored 4 patients who were being taken off life support, with their families' consent, in the hospital's intensive care unit. 2 of the 4 showed the same thing, a surge of gamma activity concentrated in a region neuroscientists call the posterior cortical hot zone, a part of the brain other researchers have already linked to conscious experience. In one of those patients, gamma wave production spiked to roughly 300 times its baseline level in the moments before death, reaching higher amplitudes than the patient's own brain produced while fully awake. The other 2 patients showed nothing of the kind. No surge, no spike, just decline. Nobody can yet tell you why 2 brains lit up and 2 didn't. Maybe it was prior brain injury. Maybe it was the medications they'd been given. Maybe it's something about the specific way each person's body shut down that has nothing to do with consciousness at all. Borjigin's team was careful not to claim that either of those 2 patients saw anything, felt anything, or experienced a single second of awareness. The data shows electricity, not experience. Nobody can climb inside a dying brain and report back. But for 2 people, in their very last recorded moments on a hospital monitor, a brain region linked to consciousness did something it doesn't do quietly. This connects to something stranger than just dying. For years, people who were resuscitated after cardiac arrest, pulled back from clinical death, have described the same handful of things again and again across cultures and decades that have nothing in common with each other. A sense of clarity, a flood of memories, a feeling of reviewing their life in vivid detail. For most of medical history, that was filed away as hallucination or oxygen deprivation noise, or simply not taken seriously because there was no mechanism to explain it. You can't study a feeling, you can study an EEG. What Borjigin's rats and Vicente's patient gave researchers for the first time was a plausible electrical fingerprint for that experience. Not proof of an afterlife, not proof of anything mystical, just a biological mechanism, gamma-alpha-theta coupling, that in a normal waking brain is exactly what happens when you pull up a vivid memory. If that same circuitry switches on in a dying brain, a memory flashback stops being a metaphor and starts being a testable hypothesis. And it reframes something most of us walk around assuming without ever examining it, that death is binary, an off switch, a hard line between something and nothing. Cardiologist Sam Parnia has put it more bluntly than most researchers are willing to, that we're still operating on what he calls an ancient, outdated idea of life and death as a clean switch when the actual data shows something closer to a process with its own internal weather lasting far longer than anyone assumed. You don't get a say in whether your brain does this. There's no version of this you can train for, prepare for, or opt out of. If the biology holds up, it's not a near-death experience reserved for people who almost died and came back to tell you about it. It may simply be what every human brain does on its way out, whether or not anyone is left alive afterward to report it. Somewhere in a freezer at the University of Michigan, there's a dataset from 9 rats that nobody thought to look for before 2013. And somewhere in Estonia, an EEG printout from a man who came in for a seizure and left behind the first continuous human recording of what dying actually looks like, electrically, second by second. He didn't volunteer for that. No one chooses the moment their monitoring becomes the data. He just happened to be hooked up to the right machine on the day his heart gave out. And in the chaos of those 30 seconds, his brain ran the same pattern it used to run when he pulled an old memory up from somewhere deep and let it surface. We don't know what, if anything, he saw. We never will. But the machine kept recording anyway, long after anyone needed it to. And what it caught looks less like a system failing and more like a brain doing, one last time, the only thing it ever really knew how to do.